2010, a farm worker was herding sheep across the empty plains of Patagonia, and he noticed something sticking out of the ground. He had no idea what it was, but something made him stop. That moment of curiosity would lead to the most complete giant dinosaur skeleton ever recovered in the history of paleontology.
Its name is Patagotitan Mayorum. It lived 100 million years ago.
37 meters long, nearly 70 metric tons. And unlike most giant dinosaurs, this is not just the story of a giant. This is the story of how science reached back 100 million years and found a living world.
This is its story.
La Flecha Ranch, Neuquén Province, Argentina, one of the most remote cattle farms in all of Patagonia. The year was 2010. A farm worker named Aurelio Hernández was moving sheep across the dry plains. He walked slowly toward a rocky outcropping and knelt down next to something that did not look quite like the surrounding rock. It was large, curved, and unmistakably different from the stone around it. Aurelio contacted the owners of the ranch, the Mayo family, who would later give this dinosaur the second half of its name. The Mayo family contacted the Egidio Ferrulio Paleontological Museum in the city of Trelew. The scientists arrived. What they uncovered at La Flecha Ranch was the femur, the thigh bone of an animal they had never seen before. Alone, it was 2.4 meters long. They began to excavate, carefully, methodically, and the more rock they removed, the more bones they found. Over several field seasons, they recovered more than 200 bones, representing at least 6 separate individual patagotans. This remains, to this day, the most complete collection of fossil remains ever recovered from any giant titanosaur. In 2017, lead researchers Jose Luis Carbalito and Diego Paul, they named it Patagotitan Mayorum. Patago for Patagonia, Titan for its size. Its skeleton went on display at the American Museum of Natural in New York is in the Menenegender lobby. But before it became a museum exhibit, it was alive. And its story begins 100 million years ago. Let us talk about size, because with Patagotitan, the numbers alone are enough to make you stop and reconsider everything you know about the possible. The most complete individual specimen measured approximately 37 meters from the tip of its nose to the end of its tail. Its estimated is 9 metric tons. That is the equivalent of 10 fully grown African elephants. A fully loaded Boeing 777 passenger aircraft, fuel, passengers, cargo, on 4 legs. At full height, with its neck raised, Patagotitan stood approximately 20 meters tall, the equivalent of a 6-story building. Its neck alone measured approximately 9 meters, nearly the full length of a London double-decker bus. The average adult human with T-Bothine is 1.70 meters tall. Patagotitan belonged to the Titanosaurs, the largest sauropods had to evolve. Individual over a meter length, removed from context, would be considered large objects in any room. But these massive bones were not solid. Like all sauropods, they were honeycombed with air pockets, a design called pneumatization. Without this pneumatization, Patagotitan's skeleton would have been so heavy that the animal might have extruded its own panels. Its 4 legs were the load-bearing columns of a biological bridge, each one carrying, on average, approximately 17 tons of living animal. Biomechanical modeling shows these animals moved at walking speeds of 4 to 8 kilometers per hour. Running was not possible. But speed was never the point. Patagotitan's power was in its permanence. Once moving, it moved. Nothing in its world rerouted it. To maintain a body of this mass, the heart of Patagotitan had to pump blood 9 meters upward through the neck, against gravity, to reach the brain. Scientists estimate Patagotitan's blood pressure may have been 4 times higher than a human being's, simply to keep blood reaching the brain.
It was so large that even its own heartbeat was an unsolved engineering problem.
And yet it worked, it breathed, it moved, it fed its young. For millions of years, this design was not just possible, it was successful. 100 million years ago, the world Patagotitan inhabited was almost unrecognizable compared to the planet we know. The climate was dramatically warmer than today. Average global temperatures were 5 to 10 degrees higher. There were no ice caps at either pole. South America was geographically isolated from North America at this time, an island continent developing its own unique life forms in complete evolutionary separation. Tall conifer trees grew in dense groves along wide braided rivers. Ferns covered the ground in thick green carpets. And in this period, for the very first time in Earth's history, the first flowering plants were beginning to appear across the landscape. Ankylosaurs, small feathered theropods, and a rich diversity of other Cretaceous life. In the rivers, large crocodilomorphs waited patiently in the shallows. Even Patagotitan approached the water carefully.
But the apex predator of Patagotitan's world did not wait in rivers.
Multiple Mapusaurus skeletons found together suggest coordinated group hunting, which would have made even Patagotitan's size no guarantee of safety.
Beautiful. Abundant. This was the world Patagotitan lived in.
How did a 70-ton animal spend its day? The answer, for most of the day, is simple: eating. Scientists estimate calories per day, with no rest days, no pause, no gap in the requirement. Its teeth were simple pegs designed not for chewing but for stripping vegetation from branches. All digestion happened afterward, in the stomach. Like all large sauropods, tumbled inside its enormous stomach, mechanically grinding plant material. Tired every other herbivore in the ecosystem. The very tops of the tallest trees.
A fully grown, healthy Patagotitan, to bring one down, would far exceed any possible nutritional return.
The vulnerable were the young, the old, the sick. Natural selection, as always, operating at the edges. Evidence from Titanosaur nesting sites across South America shows these animals were communal nesters, returning to the same areas generation after generation. There, 40 years of growth. 40 years of survival before reaching untouchable scale. Growth from hatchling to full adult involved an increase in body mass of approximately 10,000 times. We do not know what Patagotitan sounded like, but evidence from skull structure suggests titanosaurs may have, in this way, shaking the very earth beneath their feet. Patagotitans may have communicated with each other across distances of several kilometers. The remarkable completeness of the Patagotitan fossil record has given scientists an unprecedented opportunity to study the biology of a giant titanosaur in real detail. Microscopic analysis reveals growth rings that allow scientists to read the animal's age and its growth rate. The data shows something remarkable. Patagotitan was still growing rapidly at the time of death. Think about that. The fossils that stun the scientific world, that fill entire museum halls, may belong to animals that had not yet finished growing. Like all non-avian dinosaurs, air moved in one direction only, extracting oxygen far more efficiently. This made Patagotitan's oxygen extraction significantly more efficient than any efficiency, including ours. Evidence from the fossil record suggests Patagotitan was warm-blooded. It was a reproprate. Its skin, with evidence of a row of larger bony plates called osteoderms running along the midline of the back. Everything we know about Patagotitan comes from stone, from patient reading of ancient bone. And there is so much we have not yet told us. Science is abroad, and that conversation is ongoing. Now, the question everyone wants answered. Is Patagotitan the largest dinosaur that ever lived? The honest scientific answer is probably yes, or tied for first. But science requires us to examine what, named in 1993, also from Patagonia in Argentina, and known from a smaller collection of bones. A range that at its upper end exceeds Patagotitan's estimate of 57 to 69 tons. Argentinosaurus is known from very few bones, carrying uncertainty. Patagotitan's estimates rest on over 200 specimens from 6 individuals. Other contenders, Dreadnoughtus shrani, Snodoccolossus viviane, all are genuinely enormous. The truth is, we may never determine with certainty which individual species is the largest. We are working from incomplete fossil evidence. Patagotitan is among the largest land animals that have ever lived, and is the largest for which we have the most complete and reliable fossil evidence. And what the debate itself reveals is something even more remarkable. That the late Cretaceous of South America, something in that world was driving evolution towards scale, bigger and bigger. For millions of years, Patagotitan lived approximately 95 to 100 million years ago. It was 66 million years ago that date. What ended Patagotitan's lineage is uncertain. Climate shifts disrupted the agent to scale. Smaller species continued to diversify and adapt across the late Cretaceous, right up to the asteroid impact. But none would match what Patagotitan, the biological summit. That particular chapter had closed. And yet, 100 million years later, a farm worker in Patagonia knelt down next to a bone, and the story began again. In a museum, to millions of people who have never been within 10,000 kilometers of Patagonia. The pneumatized bone design has been directly studied in the development of lightweight aerospace structural materials. Research into sauropod cardiovascular biology is contributing to our understanding of vertebrate circulatory disease. The study of titanosaur growth is informing research into vertebrate aging and growth regulation. The limits of life, about what biology can achieve given enough time, have not gone anywhere. We are a young species on a very old planet. Modern humans, our species, Homo sapiens, have walked this earth for approximately 300,000 years. Patagotitan lived 100 million years ago. That is 330 times longer ago than our entire species has existed on this planet.
Time anyone was drawing on cave walls or shaping tools from stone, Patagotitan had been extinct for over 99 million years.
And yet, here we are. Understanding its biology. That is what science is. Not the accumulation of facts, but the act of reaching backward through time to find what existed before us.
Somewhere beneath the dry plains of Patagonia, right now as you watch this, there are bones lying in the dark. Bones of animals we have not yet named.
Patagotitan is the answer to a question we did not know we had been asking. What is the largest thing that has ever walked on land? The extraordinary answer was found by a man herding sheep on an ordinary afternoon in a remote field. Aurelio Hernández did not know what he had found. He did not know that the bone beneath his hands had been lying in that rock for 100 million years. He did not know that what he was touching was the largest leg bone of the largest animal that had ever walked on land. He just noticed it, stopped his horse, and paid attention. We are the only species in the history of life on this planet that has ever looked at ancient stone and understood what was inside it. Patagotitan walked this land, right here, the same Earth, 100 million years ago. The fact that we know this, that we can reach back 100 million years and find it, is not a small thing. The Earth has a history 4.5 billion years long. Life has been part of that history for 3.5 billion years. We are newcomers. And yet we are newcomers who found Patagotitan, who looked at stone and saw an animal, who asked what was this, and refused to stop asking. Somewhere out there in the Patagonian desert, there will be another discovery, another Aurelio, another ordinary moment becoming extraordinary. When that happens, and it will happen, the story of Patagotitan will become more complete, more understood, more alive. That is the gift that one curious farm worker gave us, without knowing it, without intending it, simply by paying attention. We live on a planet we have not finished discovering, in a history we have not finished reading, in a story that is still being told. Patagotitan Mayorum, found in 2010, named and seen by millions, fully understood by none, not yet. It is late afternoon in Patagonia. The wind moves across dry golden grass. The rock formations glow amber in the fading light. Somewhere beneath all that ancient stone, it is still lying in the dark, patient, silent, enormous. 100 million years is a long time to wait, but the rock does not mind waiting. Patagotitan Mayorum, discovered by a sheep farm, named by scientists, displayed in museums, known to the world, and still not fully understood. The bones are still giving, the rock of Patagonia still holds more, the science is still being done, the story is not finished. 37 meters, 70 tons, 100 million years of existence. And we found it. We found it in pieces. We put the pieces together. And from stone, we brought something back. That is what we are. A species that looks at the past and refuses to let it stay silent. Farm worker, because of a family and scientists and museums, it walks again. In the minds of everyone who has ever stood beneath its skeleton. In every child who has ever looked up and felt something too big to name.
Patagotitan Mayorum, the 70-ton giant of Patagonia. Thank you for watching.